Hello and welcome to today's webinar, How to Troubleshoot SQL Server I/O Problems. This event is brought to you in partnership with SolarWinds and produced by Actual Tech Media. Thanks so much for joining us on the webinar today. Before we get started, there's just a few things that you should know. First off, my name is David Davis of Actual Tech Media, and I'll be serving as the moderator. This is going to be a cool deep dive into solving your SQL Server performance problems. We're going to have a lot of demo, and we'll be taking your questions live at the end. So we encourage questions there in the questions pane, and we'll be doing our best to answer all of those questions. We even have a best question prize to help encourage those questions. I'll talk about that in just a moment. I also want to call your attention to the multiple resources available for download there in the handouts tab. Make sure that you check out those and download them before you go. And then finally, at the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card door prize. If you're watching this on demand, of course, the drawing has already occurred. The prize terms can be found there in the handouts tab. And then, as I mentioned, we also have our best question prize for another $50 Amazon gift card. Prize winners will be selected and contacted after the event. And with that, it's now time to introduce today's expert presenter. Welcome, Mr. Kevin Klein, head geek at SolarWinds. Kevin, it's great to have you on. Take it away.
Thanks very much. I appreciate it. And it's always good to be with you folks. I know that you're busy and you have a lot on your plate, so I'm especially grateful that you're taking out some time to spend it with me today. Hopefully you'll get a lot of value out of the session. I find that many folks do. And so if you are interested in the scripts that I demonstrate in just a few minutes, the good news is that they are already posted and online for you. So those are available on my blog at thwack.solarwinds.com, completely free. Of course, I believe you do have to be a member of THWAC, but it's just a great conversational community where you can talk about all kinds of problems as an IT pro. And there's different silos for the different kinds of conversations that are happening there. So, all right. Why don't we go ahead and move forward here? Let's see here. All right, well, and just a bit of a note about me. I've been in the business since the mid-'80s. First started working on big databases for NASA, and I was part of the team that put the International Space Station up in orbit. It's hard to believe it's been so many years since it's up there. I've written a lot of books over the year. SQL in a Nutshell is my most popular book. If you've ever heard of PASS, the Professional Association for SQL Server, I was one of the original founders and I was president for 4 years. And I'm also a Microsoft MVP, blogger, do a lot of tweeting, Facebook and LinkedIn and all that kind of stuff. All of those, I'm at KE Klein. So hopefully you'll follow me and that would be a big favor to me as well. All right, so what are we going to talk about today? I think we're probably going to spend 60% of our time on slides and 40% of our time on demo. So it's quite a heavy demo session. So lots of real world activity going on. Hopefully you are aware of how SQL Server works and know the basics about I/O and SQL Server, but I will try to give you a bit of an overview of that and some of the common patterns and practices that DBAs and architects and database developers use to make sure that their system gets the very best performance. And sometimes not the very best performance, but at least we're getting adequate performance, right? And then I'll also spend a little bit of time, not just in the setup and configuration of your I/O, but also how to fix I/O problems, how to troubleshoot them, to detect, diagnose, and resolve those. Because sometimes you just simply inherit a system that either you can't change, perhaps you bought it from a vendor, or it's extremely difficult to change because there's not a lot of people around to maintain it. That's not maybe your job. So maybe it's, be helpful for you to be able to troubleshoot that and see exactly what the problem is so that you could scope out what does need to happen in the future. So let's dive in, right? The first thing that I like to do when I talk about I/O, I like to start with an analogy because sometimes it's a little bit hard to process if I just hit you right away with all these deep technical details. So let's use an analogy borrowed from something like Downton Abbey, if you've ever seen that kind of program. And let's imagine we're aristocrats from the 18th or 19th century England, and we want to draw a bath, okay? Now, this is an analogy for we want to execute a query. However, because of the times being what they were, you have to get your bath water from a well back in those days, and you had to manually heat it and manually put it into the bathtub. And of course, your bucket isn't big enough, so you have to, for a single trip, so you have to go back and dip from the well again, heat it, pour it in. It's kind of analogous to what happens inside of SQL Server when we're performing queries and transactions. SQL Server uses 8K, 8 kilobyte data pages, of which almost all 8K is available for use for data. There's a header and there's a footer at the end of every 8K data page, so a little bit has to be used for other things besides directly for the data. So those are all stored on the database file or files in 8K data pages. When they're loaded into memory, they're loaded as an 8K data page, all right? So the well is our database files. And when we ask for a query to give us a result set, someone in the Downton Abbey analogy goes out and grabs those 8K data pages. In our case, it's a process called the buffer manager, which is part of the storage engine. So the buffer manager knows where all the data is and where it can find it, whether it's resident in cache or whether it's somewhere in the disk and it needs to pull it off of that IO subsystem and put it into the cache. So the buffer manager goes out, fills up a bucket, puts that bucket into a big cauldron over the fire. That's called the store or the relational engine. Processes your query, and then it puts that into the tub, so to speak. That it makes it available for you to access. However, as I said, it's very rare that we would issue a query that is answered in one 8K page read. Usually it's hundreds or even thousands of 8K page reads. And so in a situation like that, we got to take multiple trips to the well, which is to say to the disk subsystem. So another trip is made, another bucket is filled up using this part of the process called the access methods of the storage engine. That's how those decisions are made. And then we draw the water out of the well, we heat it up, we put it in the tub until it's full enough for you to take a bath. And it's the same sort of thing with I/O. SQL Server has to go to the disk subsystem to grab those pages that it needs. And whoops, sorry, I'll go through that again. And it might have to, make many trips. Let's say, for example, your server only has 4 gigabytes of RAM, but the database itself is 200 gigabytes in size. Well, you'll see a lot of disk activity and a lot of memory pressure on that server because it's having to put data from the disk into cache and then answer a little bit of your query and then go fetch more and answer more. And so it can be a very expensive process, and it can be easy to mistake shortages of memory for I/O problems because it has to do more shuffling and more churning of those 8K data pages, putting them in and out of RAM for you. And I'll show you how to differentiate one from the other. Okay, but that's the analogy. And so one of the things that comes out of that is you will see tons of recommendations from people like me, experts who work with SQL Server at the high end, and we will be constantly telling developers, only retrieve the data you need. So if you have a table that has 15 columns in it, please don't do select star with your where clause and your join, because now you're getting a lot more columns than you need, which will fill up a lot more 8K data pages, meaning you'll have to take more round trips. Conversely, write as tight as a where clause as you can on your SQL statements so that you filter out as many rows as you possibly can from your query. Again, fewer 8K data pages are needed, fewer round trips going back and forth to make sure all that data is in the cache to answer your query. And so time is saved. And it speeds up things significantly. So What are some of the other fundamentals that we need to get across here? Well, one of the things is you will see recommendations all over the place about how to properly configure and set up your SQL servers. And this is not a configuration session. It's about troubleshooting I/O. So I'm only going to give a brief overview of this, but basically, when we set up and configure our SQL Server IOPS, what we need to do is we have our SQL Server, and then every database is going to need at least one data file and one transaction log file. They have inherently different approaches to the way and the kind of data that they write. So the log is for transaction log activities, which is durability and recoverability. It's not really for end user activity. And so that's one of the fundamental requirements of a relational database, is that your transactions are things that you can roll back, or if there's a crash on the server, you could roll them forward and recover from that. On the other hand, data files, by default, SQL Server is going to give you one of those, but in general, I find that you're going to get better performance, particularly if there's a number of users actively using your SQL Server. I almost always start with 4 data files of exactly the same size, set up to auto grow the exact same amount. And then there's a trace flag on top of that you'll need in earlier versions of SQL Server to make sure that they all grow at the same time. All of those files grow at the same time and in the same way, for the same amount of size. So you might need 4, you might need 8, you might need 16 data files, depending on if you have tens or hundreds of thousands of end users all doing their work at the same time. Okay, so that could speed things up. Also, if you're using hard disk-based disk drives, disk I/O subsystem, then you want to make sure your transaction log is on a disk or a RAID array that is not used for anything but the transaction log. The reason for that is the transaction log writes serially, and if you're using the older hard disks, they have an armature, and that armature will write one transaction after the other, just like a scribe writing in a notebook. However, if it has to share IOPS with other kinds of activities, that means the armature has to pick up and move somewhere else and scribble, and then it has to move somewhere else and read and move somewhere else and write, and then it comes back and gets a few transaction log entries written. And in my testing back in the day, when you could only use hard disks, it was about a 30 to 40% reduction in I/O performance. Now, if you're on solid state disks, this is not as big of an issue. But if you're on hard disks, make sure that it's on the transaction log is on a separate log file, okay? Separate disk, that is. Now, another thing you can do is you can also put other objects in the database onto different files of their own. So for example, it's a good idea to put, if you have a database that has a lot of pictures in it, it's a good idea to put those in their own or their own files, if you will, because it might take a long time to recover from some kind of failure. And if those are part of the regular data file, then it's going to slow down everybody's recovery quite a lot. But if they're in their own file group, then that means that the rest of the database could come up, but the pictures that are used in the application of that database aren't yet loaded and aren't yet ready. That's okay though, because you've met your SLA now. In the same way, you might put indexes. An older fashioned technique would be to put indexes on a higher speed set of disks, and then you could be able to recover again yet more quickly, because you've got the data in one that recover at their own speed. Indexes come online perhaps a little bit later, or some other method like that. And so it can speed up all of those concerns that you have when we're in an emergency situation. It's like, okay, at least the system's up. It's not fast yet because we're still waiting for the indexes to come online, but it's still, it's still solid. So those are the kind of things we see by default. at least the data and the transaction log. And then with some advanced architectures, you may see people using indexes and blobs into their own files. Of course, from each of these database activities, set of database activities, we have a lot of writes, and those are occurring on the different tables stored inside of the database. And then we have a lot of reads happening. And the reads could be directly coming from the table and getting loaded into cache so that you can get your results, or they could be reading data only in, let's say, the non-clustered index. So if you have a large table called employees. It has everything there is to know about employees, but you frequently query just on hire date, last name, and first name, just because of the architecture of your app. If you have a non-clustered index that is in that order, the order that they're always queried in, hire date, last name, first name, SQL Server will be able to use a technique called a covering index, because the index covers the entirety of the query. So we could use that non-clustered index on hire date, last name, first name, and read just down to the intermediate leaf level page that it might need to answer that question. So it's a great way to speed up a lot of reads and write operations. So that's the basics of configuration and how SQL Server is going to work. The first technique that most people do, although people who aren't educated about SQL Server's I/O behavior, their first technique for improving performance is usually to throw more hardware at it. And that's actually what I'm trying to teach you that you don't need to do. The reason for that is because a lot of times when we throw more hardware at the problem, we don't actually even know what the problem is. So it would be like, gosh, we never get to the grocery store on time. Let's buy a minivan. Like, well, a minivan is great for hauling a lot of people, but what if it's just mom or dad by themselves shopping? And buying a minivan won't solve the problem at all. So it's one of those things where don't throw more hardware at it right away. Use these scripts I'm about to show you to make sure and ensure you're fixing the right problem. And again, when you throw hardware at the problem, incidentally, you might fix the problem. So the real problem in the grocery store analogy is that you didn't have enough trunk space. You didn't have enough storage space for all the groceries you bought. Well, coincidentally, the minivan fixed the problem. But minivans are really for hauling lots of people. So did you really fix it? But that way, well, you probably spent a lot more money than you needed to. Same thing happens all the time with SQL Server, where people just throw, oh, let's fill up the memory. Let's fill up the CPU core slots that we have in this box. And it turns out you don't have any memory problems and you don't have any CPU problems. So don't start with that as your resolution. Now, a common way to resolve I/O performance problems is to make sure that each very distinctive set of I/O workloads within SQL Server has its own SSDs or its own hard disks to perform their work. And that means segregating by the different kinds of work activities that your SQL servers do. So for example, one of the first things that we will see a smart organization do when they build an application is the application has a lot of data entry, OLTP, singleton inserts, updates, deletes, selects of all kinds. And so when we have a situation like that, and we also have a situation in which managers and the customers that are using the database, they like to do big aggregated summary reports. Well, the nature of those two workloads of reporting and data entry are conflicting. They don't get along well because the workload for reporting and BI is large aggregated data sets. And so your SQL servers need to be able to do long serial reads of millions or perhaps billions of records and aggregate and roll up all of that information. But when you're doing transactional work, singleton inserts and updates and deletes, then it is these little spot IOPS. And the big difference is that they are, those transactions are actually slowed down by having lots and lots of indexes on them. Indexes actually only help improve the speed of read operations, of select statements. So what you'll see is with a lot of customers working on SQL Server is that they start out with a generalized database for both the read-heavy kind of reporting and the OLTP work. And so what they say to themselves is, boy, oh boy, we need to segregate this out. So what we need to have is our OLTP database where there's all the people in the call center entering entries, and they're doing their writes to the customer table and the employee table and the products table and all those kind of things, the sales table. And then you also have all of your reads happening to those as well. And in this case, for the OLTP table, you have just enough indexes to satisfy all the queries needed to support the workload. So, for customers, you just have an index on the customer ID and perhaps their name or perhaps their address, but you don't index every column that could help. You keep it to a minimum because whenever an insert happens or whenever an update happens, not only does the clustered index get altered, changed, inserted to, but every non-clustered index on that table also has to be dealt with in that way. While when you're in the reporting database, you are encouraged to add as many indexes as you want. And the reason for that is because those indexes speed things up for all of your different read operations. Whoops, let me back up there. Sorry, the interface is a little different than I expected. So we'll go through this again. And so that's one thing that we'll see very, very commonly is that you'll see, oh, let's create a reporting database from this. And then the next challenge that you'll be working on after that is how to keep them synchronized. So sometimes people use things like a primarily read-only secondary in an availability group, or they might use something like replication to move data from the primary server to the read-oriented server. So there's a couple different things like that you might see used as strategies to split the two apart. Now, like I said, there's a variety of different things you might do to segregate just besides the broad workloads. So again, I only recommend this now if you're on if you're on hard disk-based systems, or if you're on one of these hybrid systems that has both SSDs and hard disks, because you never know where that data will actually reside in those tiered storage systems. So it's best to go ahead and explicitly declare and expect the worst case performance. So put your transaction logs on the different disks than the database files are. And if you have a SAN administrator, make sure that they're not using the same disks that have a different LUN address. So it looks to you like it's an E and an F drive, one for databases and one for transaction logs, but in fact, it's actually the same group of disks behind the scenes. SAN administrators are usually all about saving money, but not ensuring the best performance. And so that, again, will put you back to square one in terms of performance, okay? Also, even if you are using SSDs, you need to make sure those are configured. It depends on the specific SAN appliance you're using. Some of those are set up in what we call JBOD, just a bunch of disks. So you bought this new SAN and it has 1,000 SSD disks in it. And so there's a lot of high-end software in there that controls how disks are created that Windows and SQL Server will see. So that's a different set of challenges. But if it's a traditional approach in which the SAN administrator will be creating disk drives for you, LUNs or maybe mount points, then you need to make sure that you're choosing the right RAID array. There's typically three RAIDs used for SQL Server. The first is RAID 1, which is mirroring. So in that you have a mirrored pair, and if one of those two one of those disk drives die, then the other one's still up and running, mirroring the transactions, and so you don't lose it, right? You can recover. Another one is RAID 10, which is also sometimes called RAID 1+0, which means we have them mirrored, but then we have say 3 or 4 disks in each mirrored pair, so that means if one of them dies on the set A or set B, it's actually got backup disks in that array. So it's very resilient, especially useful for really resource intensive and money driven applications. You don't want that to go down because it's going to cost you hundreds of thousands of dollars. So RAID 10 is the absolute best, but it takes a lot more disks to make a RAID 10 array. And then finally, the most commonly used one is called RAID 5, which is striped. So you might say, I've got 3 disks in this RAID 5 array, and every transaction is written to every disk with a parity bit as well on each disk. And so that means that if any one of them goes down, it can reconstruct the lost data by reviewing all the parity bits on the other 2 disks in the 3-pair array. The only problem is it's extremely slow. It's about 300% slower than either of the other 2 RAID arrays on your write operations. It's not bad. It's comparable or close to comparable for read operations, but it's not good at all for write operations, and it's a lot slower if you ever actually have to do recovery, because it has to recover through reassembling all those parity bits and making the calculations on them. So I find a lot of people are surprised that they've always only used RAID 5, and they weren't really sure why. Well, it was a money-saving step. As I said, SAN admins like to save money-saving step, but it's actually not really good for performance if there's any significant amount of write operations happening there. Multiple files, as I mentioned. There is some old recommendations floating around from the early days of multiprocessor servers, back when the architecture was called SMMP, symmetric multiprocessing computers in the early days, when they just had, say, 1 or 2 cores or 4 cores. That would say, the recommendation would say, have a file in your database, a database file for every CPU. Or as the number began to grow over time, they'd say every 1 out of, divided by 4. So if you got 16, you should have. I'll spare you all of that long discussion there, because I've done a ton of benchmarking over the years. And basically, you're going to be best off with 4 if it's a regular application, medium workload application, even up to a couple hundred end users. 8. It's a kind of a flattening curve, so you can go from 4 then up to 8, and you'll get a boost in performance, but it's not as great as it was going from 1 to 4. 4 to 8 is a little less of a benefit. 8 to 16 is less still, but maybe needed in very busy architectures, very busy applications. And then after that, that's when you need to get the math out. Maybe you go up to 32, but it's rare that you will see a benefit from having a large number of files on a medium or light usage database, okay? And then beyond anything else, you need to have good queries and good indexing. The bottom line is, if your SQL sucks, your SQL statements are terrible, they will suck up all the resources that your SQL Server hardware has available to it and want more, so that if you throw more resources at it, it'll still gobble up all of those additional resources you've given it. So I jokingly call it Sucktacular SQL, and about 75% of the time, that's really where you need to spend your time doing troubleshooting. And so I'll show you how to get to that root cause as we move along here. Okay, so I also already talked about segregating workloads. One example is, let's say you don't have any one database on your SQL Server that's super crazy busy, but you have a lot of databases on that SQL, 40, 50, 100 databases that are all moderately busy. Well, the most heavily utilized database on that server will actually be TempDB, because all of those databases are doing activities behind the scenes in TempDB. Even if the apps don't have a lot of pound temp table name, the apps don't have manually created or intentionally created temporary tables. Anytime you have a query that has a having by clause, or a group by clause, or it has a hash join, a lot of kinds of merge joins, if it does a spool or a spill that you can see in the execution plan. Those are all reasons that TempDB will get used. And so you'll see hundreds and hundreds of different things happening in TempDB when you have a SQL server that has several dozen databases on it. And some of the other things I talked about as well on this particular slide, you can do things like splitting things out. Partitioning is not really a performance tuning technique for I/O. You'll sometimes hear people bring it up. And when it was first released, partitioning was first released as a feature. Back in those days, it was hard to manually control I/O. And so as a DBA, you might create several partitions to make sure that within this one database, a certain number of IOPS happen on these disks, and more IOPS appear on these disks, and more IOPS. That's not really very useful today. But what partitioning is really good at, and on the slide I mentioned time series data, most databases have a workload pattern in which the older the data is, the less likely it is to be written to again. You're not going to change a customer order from a year ago. That's not very common. So usually what we have in those situations is we have hot data that's being written right now and maybe have a lot of changes in the next week or two. Then we have what we would call warm data. Maybe it's the next 30 days, maybe it's the next 2 months. It varies depending on what kind of database workload and application you have. But that's experiences some moderate amount of changes. And then finally we have cold data, which once it's this old, people only look up data that age. You only use it in reports and things like that. If that's the case, then partitioning can be very helpful across those three kinds of data using what's called a partitioning sliding window. As the data ages, it moves it down the line from hot to warm, then to cold. And you can turn that last partition into a read-only partition, except when you move data each time, then you turn it back on to read-only, which means that once you back up that partition, you don't have to back it up again until the next time you have the window slide down to the next time frame. And so that saves you lots of other kinds of preventative maintenance work and activity on that partition. You don't have to do DBCC checks every night for corruption. You don't have to do backups every night, because once you've got a backup at the at the beginning of the period, it's not going to change again for another 29 days until the next refresh of the data goes in, or I should say the sliding partition slides down again. So it is useful for easing database preventative maintenance activities, but not so much for performance. All right, so I have some info here for you about things that you can segregate out if you need to. I have seen this happen where all of these things are segregated onto their own separate disks. However, those applications are typically the top 1 or 2% in terms of absolute performance requirements. So most of us won't need this. We'll just need the database files and the transaction log files, maybe TempDB on separate disks from the user databases. But generally, you don't have to segregate the rest of those things. Now, let's get to the fun part. We are going to go ahead and jump into the demo now, okay? Now, this is a reusable set of code. I have already posted this on my blog, so you can download it right afterwards. You will have to create an ID, as I mentioned, on Thwack, but it's free, and you're not going to get spammed or anything like that. So let me share my screen. All right, so what we're looking at here, again, is good old Management Studio. And there are a couple pre-troubleshooting steps that I would encourage you to make. The reason they're not included as part of this script library is that they require you to do a little bit of work before you can take advantage of those steps. And I cover them in a video that's posted on YouTube. It's called End-to-End Troubleshooting Checklist for Microsoft SQL Server. So one of the first things you would want to do is, if my IOPS have gone very, very bad. Now I want to see if anything has changed, because no one complained about this the same time yesterday, or perhaps the same time last week. So there's a couple different ways you can keep track if there's any changes in the system, and I show you those in that video. For example, you can use SQL Server Audit, you can use SQL Server Change Data Capture, and you can also use SQL Server DDL triggers. So that someone changes a stored procedure and now it creates a new big temp table, and they didn't tell you, they just snuck it in, one of the devs snuck it into production. And the next day, none of your backups worked because tempdb filled up with this new temp table from the stored procedure, and it slowed down all kinds of activities on the SQL Server, and then all the backups didn't get done in time. Well, you could see if somebody changed anything in your databases that you're responsible for. So knowing if anything changed can make troubleshooting a lot easier. The second thing, too, is to look for any errors before you actually spend a lot of time troubleshooting. The reason for that is I have spent many an hour over the years thinking that it was whatever I was working on most recently. And let's say I was helping one of the dev teams write some code. And so I'm like, oh gosh, it's really slow now on the IO because of this new application that they're working on. And so I'd spend all this time trying to troubleshoot and improve the IO performance of these queries, when in fact, if I had only looked first at the Windows event logs and said, okay, oh, well, look at this. I'm getting a ton of DNS errors, or I'm getting lots of Active Directory errors. This helps you identify whether it's even inside of SQL Server or not. A lot of times, if your router is getting flaky, then it'll be really slow on that branch of the network, on that subnet. And so maybe that's your problem. Also, there's SQL Server errors, and there's separately SQL agent errors. So check those before you actually jump in to troubleshooting. However, once you're into troubleshooting, the first place to always start is weight statistics. This was not available before SQL Server 2005. And then SQL Server 2005, it was kind of hidden. Back then, they called it UMS stats instead of weight stats. And what you want to do with your weight statistics is you want to make sure you're fixing the right problem. So weight statistics are what will tell you whether the real issue is you don't have enough memory, and so IO is constantly getting thrashed trying to fill memory with the result sets that it needs. So in this case, I'm using a query from my buddy Paul Randall at SQLskills.com, and this has two components if you've never used weight stats before. First, there's a CTE that selects all of the weight stats except for those that are part of the normal organic operations of SQL Server. So for example, SQL Server uses Service Broker internally to do a lot of its own work. And so we're not going to look at the Service Broker weight statistics, because in this case, I haven't written an app that uses Service Broker. So if I have any weight stats in those categories, they would be a false flag. They would be a red herring and take me down the wrong path. So we're going to exclude all of those kinds of things. And that's in the CTE. And then from that, we're going to extract and format some information for us. And in this case, we're looking for those that are consuming up to the top 5% of weight statistics on the server. So when I look at this SQL Server, I see that I do have one weight statistic that is specifically related to IOPS, and that is IO completion. And we can see that as a percentage of the total server wait time, it's only 13%. And that actually sounds like a pretty reasonable ratio of waiting for IOs to complete. And notice, one of the things about troubleshooting is that you get used to seeing related problems kind of clumping together, okay? And you correlate against other metrics to see if is it problem A or is it problem B, which takes me down a different path? And in this case, look at this. The number 3 is IO completion, but the number 4 is lock mutext intent exclusive, and then number 5 is lock mutext update locks. And when we add those up, it's close to the same amount as IO completion. So my guess would be that I have a lot of IOPS that are started but cannot complete because they are waiting for an exclusive or an update lock on those records. So actually I would say, oh, you know what? Yeah, it surfaces as related to IO, but really what's happening is the tables aren't indexed very well, or the queries aren't written very well. And so they are waiting on their locks more than anything else to complete. However, we'll drill down from here. Okay, so first, make sure that IO is part of the wait statistics you're looking at. If you want to look at all of the wait stats you're having, just comment out the having line here. So instead of the top 5% of your wait statistics, whoops. Then we can execute this and we can see, okay, async network IO is up there. Latch is a memory wait, latch exclusive. Then we see page IO latch SH. So that means hard disk activity, or I should say disk activity, whether those are hard disks or solid state disks. SH means shared. So by seeing this one here, I know that this is select statements. And then page IO latch EX means write statements like insert, update, delete, and merge. So they're not really significant, either of these. So 0.3% of the total waits are for read operations and 0.21 are for write operations. Not so much directly related to the speed of the hard disks or other kinds of IOPS. But let's pretend those are very high on the list. So then what we want to do from here is we want to, at least in my case, the way I like to do it is I like to get the full context, the lay of the land, what's happening inside my server. So the next thing I'll do is I'll take a look at all of my databases and see how busy they are in terms of IOPS, right? So this is the different databases, and lo and behold, just like I told you, TempDB is my busiest by far. 71% of the total IO activity on this server is in the TempDB database, 27% is in AdventureWorks, and then a little bit in MSDB and Catawba and a couple others. We can look at these then by the kinds of IOPS happening on the different objects in that database. So here we're looking at a DMV called DMIO virtual file stats. We looked at the same one in the previous query. So in this case now, we're breaking it out and we're seeing both the percentage that are reads and the percentage that are writes. And again, this is to inform me contextually, you know, is there something weird happening on that big data warehouse that should be normally just tons of reads, and suddenly it's appearing at the top of the list for writes? Scoping me in, okay? This is a kind of information overload. This one here, instance-wide view since the last reboot. And so this shows me not only by the database, but also if the database has lots of different files. It is possible, and we do see it happen occasionally, not very often, but sometimes the data files are different sizes. And so SQL Server will actually allocate the amount of IO differently according to the size and the amount of free space in the file. Also, SQL Server will keep track of the IOPS if, let's say, 2 of the disks for a database are on F drive and 2 are on G drive, and one F drive is SSD and G drive is hard disks. Well, that will create an enormous amount of weights and latency on your queries against the database, because the table could even be spread across those depending on how you set it up. So here we can see the number of reads, the amount of bytes. Whenever you see IO stall, that means SQL Server went to perform an IOP, but had to pause because there's no resources left to answer that. So if these numbers are exceedingly high, it may be cause for concern. Now, stalls are kind of normal. They happen all the time. It's only when they're exorbitant that you want to get worried about it. And again, we can see the number of reads and writes, and then we can see them in milliseconds, just the raw number of stalls, and then the size on disk, okay? Perhaps we're just looking at latency, and this might be something you would use quite a bit on Azure databases because, you know, it's all the way out there on the internet somewhere. So now we want to look at the latency, the milliseconds or the seconds it takes to get responsiveness on each of these databases. And so we see here that our average latency on TempDB is 29, and we have two files for this, and it's identical. It's 29 milliseconds average read, and it's about half a second average, or 4,000, that would be about 4 seconds average latency per write. So that's a little bit more than I'd like to see actually on TempDB. Again, we have IO stalls, we have the number of times it's read, and so forth. So again, if I have a database that's primarily dedicated to one application, this helps me make sure that there's not something weird happening somewhere else on the system. IOPS within a database, also very, very useful. So this is the number of updates that are happening per object in your database, user files. And so we see that almost all of it is on person, about 10.1%. And then sales order header is about 1% of the updates, and then everything else is minuscule. At the same time, how many reads, how many select statements are happening? And so we can see that everything on these different tables in this query are as a ratio of reads to write. It's almost all reads. They're all scans here. All right, let's find out a little bit more. So in this case, what we're looking at is the different objects in the AdventureWorks database and how many operations are happening against these. Okay, this is both seeks, scans, and lookups, singleton lookups. So this tells us on this database which of these are the most busy in terms of just raw transactions happening per database. So we've kind of scoped it from the instance is slow. Is it wait stats? Yes, it is wait stats. We see IO completion as one of the big ones. Okay, which database is it? Well, it's almost assuredly the AdventureWorks database. Okay, within AdventureWorks, which table or tables or indexes is it? And so we can see that sales order header and person are getting the lion's share of all that activity. Now, what about, you know, what's the smoking gun? What's the SQL statements, the queries that people are writing that are taking up the most IO? Maybe those need to be tuned, especially in light of locking, because we saw that as significant wait statistics there. So when we look at this, we get a whole bunch of queries back, and we could go and then pull this query code out, put it in Management Studio, or even better, we could put it in Plan Explorer, which does an even better job of showing you execution plans. And we can find out what's the problem in that. That's one way to look at it. I have several other ways for you to look at it here. One, this is kind of the super, if once you get really used to your systems, you might only look at the wait stats, and then when you verify that the wait stat is of the type you thought, skip here to this specific query written by Jimmy May. And so let me execute this for you. What it does is it collects all the pertinent performance metrics of the queries that are still in the plan cache, as you can see from these DMVs here, query stats and so forth. And then you simply change the order by statement, whether you're worried about CPU, reads or writes, physical reads in this case, since we're troubleshooting for IO. And it could be for memory and so forth. And so let's pull those out. So it's going to be a similar result set to what we just saw, except now it's giving us a lot more detail if we scroll across. Like okay, we've got some that were executed on September September 22nd, right? We've got the number of times it was executed. That's particularly important to note because sometimes you're in a situation where there's no big monster query that's causing the performance problems. It's small queries that are invoked thousands of times or hundreds of times even a second, death by 1,000 tiny cuts. So we can look at it this way. Average worker time is how much CPU it's getting. Average physical reads is how much it's taking to read the data. Logical reads is the data read directly out of cache. And so we can tell just by looking at these different ordered metrics, which are the most resource intensive queries according to specific various metrics, and go from there, okay? Now notice over here on the far right, plan generation number, and one of them is at 56. Well, we know that that particular query is recompiling all the time. So that one might be due for a tune-up as well. Now, once I have isolated the select statement or transaction, an insert or what have you that's causing the problems, I do also like to correlate the result sets against other values. So for example, I might look at buffer cache hit ratio if I'm looking at memory, or page life expectancy if I'm looking at memory. So that will tell me if I'm experiencing any memory pressure. I have a stored procedure here that you can download based on a poster I wrote a while ago that had all of the different perfmon counters relevant to SQL Server. And so I'm not sure if I can just execute. I think I created it here in the database. If not in master, then it might be in AdventureWorks, just to show you what that looks like. Yeah, there we go. And so you can see the different kinds of perfmon counters that it's collecting, workload indicators, metrics there. And then we get to use user and lock situations. So we can see if there's a lot of locking or blocking going on. And we also, if you don't know what your normal value should be, ideally, you're going to take a baseline and know what normal looks like on your SQL Server. But if you don't, I give you kind of a rule of thumb, just in case you don't have any idea where to start with some of these. So it should be less than 1,000, for example, on some of these lock values. And then we have the IO counters. So things like the access methods, the buffer manager, and so forth. So we can see if they correlate and if we have different issues happening with page splits and things like that, okay? So that's correlating with perfmon counters. And then we also have some other things we could look at. For example, if you know the problem is happening right now, we could just grab all of the user activities and look at DMOS waiting tasks. And this is by SPID. So we could see anybody who had a SPID that was waiting for IOPS. And then we have a couple other ways to look at that. For example, if somebody is waiting on IO, anytime we look at the pending IO, that's important. And we can the previous query allows us to correlate it to a specific end user. And then sometimes we have a situation where maybe it's not a user. Maybe it's something like a process, like the log writer or one of the buffer logs or something like that. So if we had a problem with, in this case, the log writer, this particular query would reveal that, okay? All right, so that's how we go from the top of the funnel, could be any problem, down to the root cause and troubleshoot it in that way. So let me stop sharing my screen and we will wrap up. Okay, are we back to the slides there?
We are, yeah. Go ahead, Kevin.
All right, so as I mentioned, there's just a couple slides left. So here's the DMVs to remember from the demo that I just showed, and I'm going to test you on these when we get to meet in person at some point in the future. Then there's also some other kinds of, oh, actually I have them listed here, like page splits, number of IOPS, and things like that. So remember those, and that'll put you in good stead. The main ones to remember: DMOS wait stats, and then the query stats joined to these other tables in different ways so that you relate it to a specific query to the performance metrics, and you could tell exactly which queries are the ones causing the problem. Okay. However, having tuned thousands of SQL Server databases over the course of my career, if you're leading with, let's change the hardware first, throw more hardware at it, I'll tell you, probably somewhere between 70 and 80% of the time, that's going to be wasted effort and wasted money. Usually the problem is spectacular SQL, really badly written SQL, and your tables and your indexes are not configured properly. After that, we then have some things like maybe your DBCC checks, your batch jobs, your backups or index rebuilds, index reorgs, statistical updates. Those kind of things are conflicting within users. And then finally, at the bottom is typically hardware, okay? Now, one last thing to mention as we're in our last minute or two is that if you have SQL Server 2016 Service Pack 1 or higher, or any version of SQL Server that's in Enterprise Edition, there's a fantastic feature called data compression. And you can apply that at the row level or the page level. And we have done a huge amount of testing of this at SentryOne, that is to say at SolarWinds. And the performance gain you get from turning this feature on, particularly page level data compression, is massive. Usually about a 60% improvement in IOPS and in memory handling and in space savings on the hard disk or the SSDs. And usually it's at a cost that's minimal. A lot of people have said, well, I haven't enabled it because, you know, it's like a PK-zip algorithm and I don't want to lose 4 or 5% CPU. Well, we have tested here at SolarWinds, and what our tests show us is that unless you have an unusual workload, it only costs you 0.6% CPU. So in normal circumstances, just a regular old workload, it's almost free. And so it's like free performance boost for IO significant situations. So definitely take advantage of that. Now, same kind of summary stuff I've been going through as before. Start with your IOPS. Also, make sure it's outside or inside a SQL Server before you really get underway. And then cross-reference your weight stats with the other perfmon counters and things like that I've showed you. Take a look at those in reference to the different queries that are happening at the time and the kind of weight statistics they are racking up. And then with that, you should be at a root cause. So let me hand it back to David for a minute. And David, I believe we have a poll we need to put up.
Absolutely. Yeah, we do, Kevin. I'm going to bring up that poll right now for everyone out there in the audience. I want to encourage you to respond here to this poll. The question is, what additional information would you like about the SolarWinds solution that you just learned about here? Pricing, personal demo, maybe you just like to try it out for yourself. So we'll leave that poll up there. We've got just a minute or so here left in our session to maybe take a question or two. But we encourage you to respond there to that poll. Kevin, I got a couple questions here. Maybe we have a minute or so for. Cody is asking, can we get that blog address again? Maybe you mentioned something in your presentation.
It's actually just after the Q&A slides, but let me copy it and put it into the. Let me copy that and put it into the chat there.
Yeah. Okay. Yeah, we'll bring that up here in just a moment. Let's see. There's another one here. Sean is asking, we currently use DBA for SQL performance troubleshooting, but have built a new server to migrate over to SolarWinds SQL Sentry. One thing our DBAs always point out is the IO weights, but according to our hypervisor, the VM and host see almost no IO weight. Does SQL Sentry allow for more insight into issues of this nature?
Great question, and the answer is yes. If as long as you're running on Hyper-V or VMware, there is full monitoring of the VM as well, and so it's not uncommon to see the VM disagreeing with what Windows sees. And so it's one of those things where we've had customers call us and say, you know what, I loaded your product up just so I could prove to the VMware administrators that the VM was a problem, and they kept insisting that it wasn't. So once I showed them this data, they said to me, "Hey, can we have that product too for their virtual machines?" So the cool thing is about SQL Sentry is that it's not licensed by console. So if you do have a VM management team that is separate from your DBA team or say your developers, all of those people can have a console. It's licensed per server that you're monitoring.
Oh, okay.
So if you're monitoring the dev server, the dev teams can look at the console for those. If only portion of your servers are virtualized, then the VMware administrators can look at those. And so you've got a lot of different options there. If you have a license, then you can share the console with anyone.
Excellent. Yeah, that's a great point. Well, there's so many more excellent questions out here. I'm afraid we don't have time to answer all these live. We're going to have to get back to these electronically. Before we go, I want to remind everyone out there to make sure you respond to the poll. We do want your feedback on that. Kevin, this has been like an amazing masterclass on troubleshooting SQL Server I/O problems. So thank you so much for sharing all your excellent wisdom with us. Before we go, if folks want to get started with the SolarWinds solution, what do you recommend that we do here? I know we have a couple of resources.
Right, we do, and there's my blog address again, by the way. You can email me, of course. I'm always happy to help and direct you to the right people. And then we also have one last slide that I want to share with you, in which you can see each of our major products: DPA, DPM, and SQL Sentry. So if you're curious, what's the difference? And I'll make it just a sentence for each of them. DPA is our broadest tool. So if you want one pane of glass for Oracle, SQL Server, MySQL, DB2, Sybase, DPA covers all of those, and it's primarily a weight stats monitoring tool. DPM, on the other hand, is I guess you could say, our SaaS tool. So if you're writing software as a service, and maybe you have some NoSQL databases, like you've got Redis or something like that, as well as SQL Server and Oracle, then you can monitor those. And it primarily focuses around the site reliability engineering model, which uses what's called the 4 golden metrics: latency, errors, throughput, and number of user connections. So finally, there's SQL Sentry, which is the comprehensive tool for SQL Server users. The idea is you are responsible for very important data systems, and you don't want to have to go to the server team to get permissions to pull Windows perfmon counters, and separately to the VMware team to pull that. You need to be able to solve those problems at once, right? And so it will show you from the bare metal to the VM host to the VM guest to one or more instances of SQL Server, as well as analysis services, integration services, and reporting services. So that's the one you want if you're going to do very comprehensive maintenance or upkeep, troubleshooting, reliability on that SQL Server.
Got it. Okay. Yeah. Thank you for explaining the difference there. I want to point out to everyone out there in the audience, you can click any one of these links. They are hyperlinks. Just mouse over those, and that'll take you to the respective web pages. Check out the handouts tab there. There's 4 excellent resources to download. And then finally, of course, thank you, Kevin, for sharing your knowledge with us today. Been a great presentation and demo.
Well, thank you so much, David. I appreciate your time too.
And of course, thank you to everyone out there in the audience for joining us on the webinar today. Before we go, I want to announce the winner of our Amazon $300 gift card. This is going to David Neisser from Ohio. Congratulations. We'll reach out to you to deliver your prize. Thank you, everyone who joined us on the webinar today. Have a great day, and we'll see you next time. Bye-bye.